Hi, again, this is me, Ole, coming in from Germany. And I want to talk to you about DNS and all the things you never dared to ask, right? I promise I take every chance to tie it back to Elixir. We at DNSimple run a little bit of Elixir, so I hope that helps. So I want to pitch a startup idea. I had the best startup idea ever, right? And I'm pretty sure VCs will love it and venture capital will just go for it. Did you ever had the thing that you just ate, but you're still hungry? I learned you always start with a problem pitch. And I want to propose a solution to you all. So I think what sounds really cool to me, especially to my Italian colleagues, is what if we combine pizza and chocolate? I think this sounds like the best thing ever. And because we want to ship it over the world and I don't want to leave the house to get it and sell it, let's freeze it up and ship it to customers. I think this is $1 billion idea. But in order to make it happen, we need a domain. Good for you and me. I work at DNSimple, so I know a few people who can actually sell you a domain and know quite a bit about DNS. And this is the rabbit hole I want to take you to. So what about we register www.frozen-chocolate.pizza? That sounds like a great domain name to actually buy frozen chocolate pizza, right? Have you ever wondered, like, how does this work? How does this work actually? So I welcome you to follow me into this rabbit hole, and together we can discover what's behind that. It all starts with the registrant, which is you, me in this case. All of us wanted to buy domain names, and we go to the registrar, right? In DNSimple, we are a registrar too, and we are also a reseller. We are both, and then the registrar is meant to help you to buy domains from registries. So the registrar in turn goes to the registry. And then the two of them, so the registrar and the registry, they use the Extensible Provisioning Protocol, in short EPP, at least for the most part, because in domain and DNS land, there's always an exception to every rule. This protocol, as you can tell by the RFC number, is quite old already. It's XML based, as said, it's quite old already, and they really mean the extensional part. So all even current features like DNSSEC are in this protocol, because in XML you can just append nodes wherever the fuck you want, and it, for the most part, also works. In the EPP protocol, we are talking about 3 different parts or objects. First, it's domains, it's hosts, and it's context. So we have those 3 entities in the Extensible Provisioning Protocol. And on that protocol, on all of those 3 entities, you can do 2 types of queries or commands. You can do queries and transform commands. Queries are things like check, info, poll, and transfer that do not modify data on the registry, so on the domain name or on one of the entities. And then the transform commands like create, delete, renew, transfer, update, those are meant to actually change things at the upstream, right? So on your on your resources. It would be too easy if you just have like one RFC. So we actually have one specific RFC per on one of all of these entities, and they define how this general idea of the EPP protocol map to those entities. We wanted to look at domains, so let's have a look at how this looks like. This is an example payload, and it's actually a valid one. I extracted it from actual fixtures that we own for the most simple use case. And here you can see the domain name, you can see the period, the name service you want to do, the registrant ID, contact, all of that, even the super valid auth code, it's all in here. But who are we talking to actually? Like who's receiving that? So in order to understand this, we need to look at the domain again. So frozenchocolate.pizza consists of a few things. And in order to understand who we're talking to, we need to take a look at the last bit on .pizza, the so-called top-level domain. Well, actually, it's the so-called eTLD, the effective TLD. There are many of those because it's never just the last part that follows after the last dot, right? There's co.uk, com.au, DEVU. Well, that one is not actually true. It's another one of those exceptions. So the effective TLD, the eTLD, can be more than just the last part after the dot. And there are multiple variants of those. So there are country code TLDs, DE, ES, FR, IS, US, SC, AF. So they always represent a specific country. And then there's generic TLDs like .com, .org, .ngo, .info. And there's the last category called new GTLDs, where things like best, .capital, .app, also internationalized ones, the ones I can't pronounce, and also the very geographical ones, like regional ones, like .london, and also .pizza. So it's a new generic TLD. So who owns .pizza? .pizza is owned by Donuts. It's a registrar, an N registry. It's one of the very big players, and they own over 240 GTLDs. So it's a business. It's a big business, actually. But have you ever wondered how new TLDs are actually made? So let's continue down that rabbit hole. And no, TLDs are not made like this. So let's give them some privacy. In order to understand how TLDs are made, we need to have a look at all the different players in the game. And the Internet Corporation for Assigned Names and Numbers is the key player here. Its role is to be responsible for the technical management of DNS root zones and also the IP address space. It's the governmental advisory board that has representatives from 111 states, 108 UN members, the Holy See, Cook Island, Niue and Taiwan, Hong Kong, Bermuda, the EU, and the African Union as well. So how you might have wondered already, how do you get your own GTLD, right? And I want to spill one of our secrets. I can tell you how this is possible. So you can get your last name as a TLD. So first, you need to go to ICANN and apply for just around 190K US dollars, and 50K of them needs to be cash deposit. You also need to provide the following. So you need to provide the proof of legal establishment, all your financial statements, and a community endorsement in terms of when you have a community domain like .js, for example. You need some government support or non-objection for local ones. You need documentation of third-party funding commitment, and in case of conflicting applications, you need to win the auction, right? So there's an auction, and this is basically where you can spend unlimited money. Then you only need to pass an extended ICANN evaluation. Simply manage and operate your own registry infrastructure, including authoritative DNS, WHOIS, escrow, and shared registry systems, and profit, right? And this system leads to funny headlines like that one. So the ICANN has no idea how they want to spend the 240 million US dollars they won from auctions. But wait, we were talking about something else. What did happen to our request? So we wanted to register frozen chocolate.pizza, right? We just sent it to Donuts. So we got a response. And as you can see in the message, the command completed successfully. So we managed to secure our domain. And this info now is at the registrar level. And the registrar will then go back to the registrant and tell you, yay, that works. So we got the domain safe. That's pretty cool. But wait. I mean, the domain is cool, right? Frozen chocolate pizza is nice, but my CEO friend told me that shorter domain names are better. So what I really want is chocolate.pizza, right? This is where the money is. Like, this is where I need to spend my efforts now. And this is what I want to talk to you. I have bad news though. The domain is actually taken. But good news again, we can buy it. It's on the so-called aftermarket. So someone registered it, is squatting on it, not using them, and then offering it to anyone who's willing to pay around 1,000 pounds. I did this presentation before Brexit, so I think it's a little cheaper now, actually. So let's imagine I really do want to spend all the money now, and then I buy it from the other one, but I cannot register it because it's already registered. So how would I get this domain now, right? Because I want to own it. So I need a domain transfer. So brace yourself. This slide is a big one, and we will walk to it bit by bit. And we can have a look at how domain transfers actually work. And everything starts with you or me or all of us, whoever wants to have the new domain, right? You go ahead and request the transfer at the gaining registrar. So this would be my registrar. This would be DNSimple, because someone else owns the domain somewhere, but I go to DNSimple and say, here, I have the auth code and I can get this. I wanted this thing, right? I want the domain. And then the gaining registrar gives me instruction that, wait, you need to get the auth code and unlock the domain. So I go to the losing registrar, and the losing registrar has to provide you the means to get the auth code and unlock the domain. And with that, the gaining registrar can go ahead and do its bit in a bit, though. So the next step the gaining registrar has to do, it fetches the whois data and then sends the FOA to the RNH or AC. So that means for normal people that the gaining registrar sends the form of authorization, so a standardized letter or email, to the RNH, the registered name holder, which is the person in the whois data, or the AC, which is the administrative contact. And without that form, without that signed FOA, the gaining registrar cannot go to the registry in order and provide the auth code to the registry and actually give them notice, like I have an auth code, I have FOA, so I want this domain in my account. So given I provided everything, the registry will then go ahead and provide a so-called e-notice. That's all ICANN regulation terms, to both registrars, so the gaining and the losing one. So the gaining understands everything was correctly provided and it actually started, and the losing one, and this is interesting, only gets the idea that they are actually losing a domain because they didn't really know for sure before that. And this is the key, like this is the secret. Like if you want to take anything cool away from this presentation, whenever it tells you like domain transfers just take that long, this is why it takes so long, because then the domain enters an idle state where the losing registrar has a chance to neck the transfer. And if they don't act, it's auto-acknowledged after 7 days. So this is why everyone tells you domain transfers take 7 days, while actually it means that the losing registrar just doesn't have the means or doesn't want to put the effort to actually acknowledge the transfer prior to that. And there are very little reasons to not acknowledge a transfer. One of the valid ones is that the losing registrar already paid money for the domain, but you didn't pay the registrar. And after that 7 days, the transfer gets effective. So this is all it takes, right? It's very simple. But remember, kids, always start your transfers on time. Like that's the second thing. If you want to take something away, like always start them on time, because even though it's just theoretically, there's theoretically a way to make it faster, it might just take time. So we have chocolate pizza, but how do we turn it into money now, right? We're not done yet. Like we own the name, but we want to turn it into money. So next step is we pack it up and send it to our customers. But in order to do that, we need some sort of like a web shop. Like where would people order? I think nowadays phone orders are not a thing anymore. So I heard that people love this internet where they can just shop online. And in order to do that, they need to go to my website. You are all aware, I suppose, that websites are not running, the internet is not running on names, it's running on IP addresses. In this case, in this example, it's an IPv4 address. And that name gets translated to an IP address. But have you ever wondered, how does this actually work? Like, what's the magic? So let's continue. We are already that deep in the rabbit hole. I think it's worth now to pull through. So what is this thing in the middle? This thing in the middle is the domain name system, or DNS. And you might have heard that there are actually two things in computer science that are really hard. That is naming things and caching, and off-by-one errors. So welcome to DNS. We have naming things and caching. It's a tough challenge, but it's also solved. That's cool, because I want to give you some one-hand DNS knowledge. It's UDP, unless it's not UDP, and it's TCP, but it's usually UDP. It's a binary protocol, it's not encrypted, and it's actually defined across 52 different RFCs since 1983. And it also works backwards, right? You can also resolve IP addresses to host names. And that's just rarely used in modern technology. So let's take a look at how this works. You have your process on a computer, usually your browser, that wants to know from the operating system, what is the IP address of chocolate pizza? The operating system then goes to a resolver. Usually there's multiple resolvers in place. Let's now just assume there's one resolver here. And that resolver in turn then doesn't know the answer. If they doesn't know the answer right away, because they do caching, they need to know where to look. So they dissect the domain, they see .pizza, and they know that they need to ask the root servers, like, where is .pizza? Like, where can I get more information of that? But have you ever wondered who actually is operating the root of the internet? So take a minute and relax. Let's talk about who actually owns the root servers of the internet. So there are 13 different root name servers distributed globally. We have to say it's different root server names because there's like a ton of physical machines, right? And let's walk through them. Who owns them? So the first is VeriSign, the company that also owns .com. There's the University of Southern California, Cohen Communications, which is a multinational ISP based in the United States. There is the University of Maryland, NASA, Ames Research Center, Internet Systems Consortium, which is a Delaware-registered nonprofit co-op that supports the infrastructure of the internet. I don't know what that means. Wikipedia does. It's the US Department of Defense, US Army. Don't see anything wrong with that, though. NetNode, which is another nonprofit, neutral and independent internet infrastructure organization based in Sweden. So take note, Sweden, right? We are just at I, and we found the first one that's not in the US. There's a VeriSign again, funny, right? So it's 13 root name servers, but only like 12. I think one just got run out of business, and VeriSign was so kind and take over. There's the RIBA-NCC, which is the Regional Internet Registry for Europe, West Asia, the former USSR, which is headquartered in Amsterdam with a branch office in Dubai. And ICANN, they also operate one. And the White Project, which is an internet project in Japan founded by Keio University, Tokyo Institute of Technology, and the University of Tokyo. Right, huh? This is not a secret. Like, this is on the internet. You could have known that. I didn't before, and when I prepared this, I was kind of shocked. And I think there's many things wrong about that, and it's on the broader society to fix it. But let's get back to our funny resolver friend here. So now the resolver friend knows where to look for .pizza because the root name servers told them. So the resolver now asks the .pizza name servers where to look. But wait, who's actually operating those name servers? So remember, that is owned by Donuts. So now the name server told us that they don't know where the domain is, like actually the records are located, but they know who we can ask. So we can ask the authoritative name server. So the resolver then goes ahead and asks the authoritative name servers. And then finally, the authoritative name servers have the actual resolution of the name to an IP address that we actually asked for, the so-called A record. And then the resolver can go back to the process on your computer and tell them the answer. And then your browser knows what IP to connect to. That's awesome, right? This is an excerpt from the comic that we did at DNSimple. It's how DNS works. It's really cool. And if you want to learn even more about what I just briefly described, I really recommend to check it out. So unfortunately, we are really running out of time. So we cannot finish our chocolate pizza adventure. But there's one last thing. I want to tell you the third secret that I want you to take away from this presentation. And when there's anything to know about domains, which will make your life easier, as well as mine, because at DNSimple, every one of us does support. So I want to tell you how you can transfer your domain without downtime. That's actually a pretty cool thing, and it's possible, and it doesn't even take that much. So to transfer your domain without downtime, you first change the name servers. So at your new domain hoster, you'll go in, set up the authoritative name servers to respond to your zone, change name servers, and only after that, so only after you've made sure that the name server change worked flawlessly, right? You go in, wait for 5 days, and hope that the transfer goes right. That is everything I got for today. I'm from DNSimple. We have a great API client for Elixir. I really recommend checking it out. We have a booth here. Enrique's hanging out there. He's like working a bunch with that. We also at our booth, we raffle a yearly pro subscription. We raffle stickers, t-shirts. I will be hanging out as well for a bit. And that's all I got. Now it is really time for chocolate pizza, because that thing, I did not make it up. I shit you not. We have time for questions. And if you don't have questions yet, there's like tons of stuff that you might wonder, like or the various record types, caching, and how I like 1.1.1.1 and 8.8.8.
Well, thanks everyone, and thanks again, Ole. Good recovery.
Always.